Hello, my name is Mark Ewaldson, Dr. Ian from La Cañada High School. Today we're going to be talking about it's the seventh session of the air pollution unit. It's about acid rain. Uh, Basically, we're going to identify a research method, design, and or measure about acid deposition and what causes it. The sources of NOx and sulfur dioxide are NOx and sulfur dioxide are primary pollutants that cause most acid deposition. The major sources are coal power plants, metal factories, and vehicles that burn diesel fuel. NOx comes from vehicles that are very, very efficient, that have generally high heat. Therefore, it's basically taking the nitrogen in and combining it with oxygen from diesel engines and coal power plants. How do we limit acid rain? You can see here that between 89 and 91, there was lots of acid rain in the Northeast. However, in 2009 to 2011, it went away. How? Well, we reduce it by reducing NOx and sulfur dioxide. When we have higher car standards for the industry that builds the cars, we use more public transit. We use more efficient electrical, such as wind, solar, and so forth. Since the passage of the Clean Air Act, acid deposition has greatly decreased. So how does it come about? Sulfur dioxide, either from coal or NOx from cars, goes up into the atmosphere as a primary pollutant, combines with with oxygen and water to form nitric acid. Notice how it has the H2O combines with that. The water combines with the sulfur dioxide and oxygen, forming sulfuric acid or nitric. These go into the clouds and they come down. Now, it comes down as the sulfur dioxide, sulfur trioxide, NOx, and the acidity. Acid rain has a higher hydrogen concentration because it's acidic. It decreases the soil pH. It can limit tree growth in forests downwind from major SOx and NOx sources. In fact, frequently it used to be that downwind east of Germany, a lot of the forests there were devastated. Environmental effects. The more acidic, the lower the pH. It causes water acidification and soil acidification. You can see here that it affects, here is a regular root. This is one that has been affected by acidification, normal acidification. Hydrogen ions displace or remove positively charged nutrients such as calcium and potassium from the soil. Also, hydrogen ions can make toxic metals like aluminum and mercury more soluble into the soil and water. This can slow the growth of plants and animals living in the soil and or water because there's more and more of this positive, more acidic in the environment and the aluminum and other things. Environmental effects of acid rain. Some species have different tolerances. So you can see here 7 to 7.5 neutral. As you go down farther and farther, there are less and less organisms that can handle it. pH tolerance. As pH decreases, becomes more acidic, it becomes outside range for many species, and therefore the population declines. When pH leaves the range of tolerance, in other words, where they can survive, they die. They lose the ability to reproduce and or they die. Why? Because aluminum is very, very toxic. It disrupts the blood flow of the osmolarity, meaning that it makes it so a lot of the cells are going to die, disrupt. There are indicator species, meaning species that when the acidity goes too high, they are very, very susceptible to this. You can notice here there is, as we get here, the algae is going to increase. Here we have some crustaceans that die off. Fish, so forth, are going to be dying off. So indicator species are going to have problems there. So, for example, the white moss or algae population indicates a pH of less than 6.0. High crustacean population indicates a pH greater than 6.0. How do we stop it? We can use limestone or calcium carbonate. We crush it up, and this will neutralize the acidic soil or water. So limestone, which is calcium carbonate, reacts with the hydrogen ions, forming hydrogen carbonic acid, which gives off the calcium. This neutralizes the acidic water in soil, moving it closer to 7.0. Sorry about the light. Regions with limestone bedrock have natural buffering ability of acid rain. But if you have a water source that is too acidic, you can crush up limestone and just add it to the soils and or waters to neutralize it. Acid rain can also corrode human structures that are made from limestone. This used to be a beautiful sculpture. You can see the beautiful fine hair, and the rest of it has been destroyed. We can limit sulfur dioxide and NOx by decreasing these primary pollutants. We can use more renewable energy sources, decreasing the coal. We can use fluidized bed combustion and lower burning temperatures in existing coal power plants, and therefore reducing the amount of sulfur dioxide and NOx being produced. We can use dry or wet scrubbers, which we've talked about before in a previous lesson. So, practice FRQ. Scientists want to examine how acid deposition impacts crustacean organisms, such as isopods, in the soil of temperate forest. To explore this question, they collect rainwater with different pH values and mist the different rainwater samples onto pots of soil taken from temperate forest. Throughout this experiment, scientists record the number of living and dead crustaceans found in each pot of soil. Can you identify a hypothesis for this experiment? Can you identify the independent variable for this experiment? Can you explain how the results of this experiment would change if crushed limestone were added to each soil pot? Thank you, and I hope this was helpful.